FabricPath sounds more versatile. Are there designs where you suggest that we stick only with VPC? Okay, that's actually going to bring us to our next topic, which is why would you not want to run FabricPath, basically? Okay, and the reason why is that ultimately when you go down to the end node, so you're going down to your end server doesn't support FabricPath. So this means that if you have a single connection to them, then you don't have redundancy, and you also don't have load balancing. So generally from your access layer switches down to the end servers, like from your 5Ks down to your fabric extenders down to your VMware host down to your virtual machine, you want to make sure that you actually do have multiple physical connectivity. And that's now what VPC Plus is solving. So VPC Plus is essentially the integration of FabricPath and VPC at the same time. But the potential problem that we run into is that each FabricPath switch has its own switch identifier. And we saw this here. What it's used for is its node identifier in the ISIS shortest path tree. So we end up in kind of this logic problem that the VPC peers from a layer 2 forwarding point of view, we want them to look the same. So we have that physical triangle that we're trying to change into a logical point-to-point link. So if we were to run regular FabricPath and VPC, the VPC peers are normally going to have separate switch IDs. So we go a little bit further with this enhancement. Now this is considered VPC Plus. Okay, VPC Plus is going to solve this problem of the VPC peers looking like separate leaves of the shortest path tree. So VPC Plus is I'm going to take the VPC peers and I'm going to assign them a single switch ID. So this means that from ISIS's point of view, they appear as one node in the database, in the link state database. Okay, so this is what we're trying to solve, is to simplify the shortest path tree for ISIS. It's also going to simplify the layer 2 multipathing. Now, in order to actually do this then, it means that the peer link between the neighbors, so this is the VPC peers, the peer link would have to run is switch port mode FabricPath. Now this also implies that if we're doing a VPC on a 7K, the peer link must then be an F1 module. Because we know we have our M1 modules that are doing the layer 3 routing, or the M2 modules. Normally that's going to be where you have your first hop redundancy protocols. So the end hosts, we're trying to do large scale layer 2, but we also need to do layer 3 at the same time. So they may be having intra-VLAN communication, but they're also probably going to have inter-VLAN communication because we need to route from VLAN 10 to VLAN 20. So somewhere in the network we still need our default gateway. We need to be able to do that layer 2 header rewrite and move packets from VLAN 10 to VLAN 20. Okay, this is where the first hop redundancy protocols come in. We saw that with VPC, they're solving some of the loop prevention logic and the usage of that peer link in the control plane versus the data plane by changing how HSRP works normally in active standby, changing that to active-active. Now with the VPC here, or VPC Plus I should say, the problem then becomes that peer link that's using to synchronize the control plane, that's now going to become a FabricPath link. So it's not a layer 2 trunk, it's not running spanning tree, this is going to be an F1 module that is running switch port mode FabricPath. Okay, we also then would need to go under the VPC domain and give both of the VPC peers the same FabricPath switch ID. So like on 5K1 we said its switch ID was 51. On 5K2 we said its switch ID was 52. For VPC Plus we would need to make sure that both of these are the same because basically we're trying to fool ISIS into thinking that these are the same switches, that it's the same one physical device. Okay, now the potential problem becomes then we're moving the peer link from some other mechanism. Now whether we're already using F1, we're not already using FabricPath. So it means that the peer link either will be an M1 port that has switch port mode trunk and spanning tree port type network, or it will be F1 that is using switch port mode trunk and spanning tree port type network. We need to migrate this to switch port mode FabricPath. This means that the VPC to the VPC Plus migration is disruptive. So it will cause traffic forwarding failures while VPC Plus is reconverging. Now there's a design guide. If you are going to do this in production, I would definitely recommend to take a look at this. It's from the last Cisco Live. It's called FabricPath Migration Use Cases, and it specifically talks about what are going to be the convergence numbers, what is the specific order that you would need to migrate your VPC design into the VPC Plus design. Because in reality, there's only 2 commands you need to do to get VPC to work with VPC Plus. It's just you say switch port mode FabricPath on the peer link, then you say the FabricPath switch ID under the VPC domain. But there's an issue then, you need to do it in a specific order. If you're doing fabric extenders, the FEXs are going to have to go offline and then they're going to have to boot up again. So there is going to be some downtime when you're doing the migration between the 2 of them. So again, if you're going to be doing that, I would look at this document. You can search by the number. It's BRK DCT-2202 FabricPath migration use case. There's a video on demand for it, and there is a PDF. I would definitely recommend to take a look at that there. Okay, there was one other thing that I wanted to show here in the control plane. I had a couple questions on about spanning tree. So let's go up to some devices in the core. Let's look back at our diagram. And let's go to 7K11. On 7K11, if we look at the show interface E21 to 2, include input packets or output packets. And let's see, that's not what I want to see. I want the input rate, not the input packets. The input rate here is 2 gig. So we could tell that this link is being used in the data plane right now. This is where the FabricPath forwarding is happening. What happens when we look at the show spanning tree VLAN 10 though? We're not running spanning tree. So the key is that the FabricPath spine switches do not run spanning tree at all. Since all of our links are FabricPath, we're using only the layer 2 ISIS routing between the different switch IDs in the shortest path tree to figure out how the traffic is ultimately going to flow in the data plane. Okay, it's only the devices at the edge, the leaf switches, that are interfacing between classical Ethernet and the FabricPath core. They're the ones that need to run spanning tree down towards the edge. Okay, again, as I mentioned before, those devices do need to be the root of the spanning tree. Since the classical Ethernet facing ports run as spanning tree root guard, they will be disabled and you're going to stop sending traffic in the data plane if they are not the root of the spanning tree. There's a question, what is the advantage of conversational learning if the spine switches have to learn all of the end host addresses? Now the key is the spine switches, they do not have to learn all the end host addresses. They only actually have to learn the ones that are currently routing over FabricPath. If the devices were only sending traffic local, so if we look back at our topology here, if I have router 3 that is talking to server 1, but router 3 is not talking to server 3 or to router 2, the devices in the core would not be learning its MAC address. It's only the devices that switch or layer 2 route over FabricPath, those would be the ones that need to be in the MAC address table, or essentially the routing table. There's a question, can we run FabricPath in one VDC and classical Ethernet in 3 other VDCs? Yes, you can. Okay, the only real limitation is what the line card is going to be. So your F cards have to run FabricPath. The M cards do not support FabricPath. There's a question, how will layer 3 routing work if you have multiple leaf switches connecting multiple spanning tree domains? It's not going to make a difference because in the FabricPath core, the traffic is going to be routed based on the ISIS shortest path tree. So it will automatically figure out what is the best path between the source and destination. There's a question, can FabricPath support multiple VLANs? And if yes, how would we filter the VLANs? Okay, the difference for this is just that we would either set the VLAN to be FabricPath or not be FabricPath. So let's do one more quick example here on the connection between, let's say, between server 1 and router 2. Actually, let's do this between router 2 and 3. That'll be simpler to change. Okay, and router 2 and 3, what I'm going to do is go to their links and change their addresses. Let's say router 2 is 20.0.0.2. Router 3 is now going to be 20.0.0.3. I now need to go to the devices in the middle and say that VLAN 20 is going to be mode FabricPath. This is the only other change that I'm going to have to make in the core. So on all the switches here, VLAN 20 mode FabricPath. Then on our access layer switches, I need to make sure that the access ports, of course, are assigned. So switch port access VLAN 20. Switch port access VLAN 20. So now I should see 2 and 3 should be able to reach each other. If we ping 20.0.0.3, and let me make sure these are the right interfaces that I use. Let's show CDP neighbors. So router 3 is on E101.1.1. That's in VLAN 20, that's correct. On the other side, show CDP neighbors. E102.1.1 is VLAN 20. Okay, let me double check my addresses. Show run interface gig 00. So this is 20.0.0.2 on router 3, 20.0.0.3, and let me flap these links to get the network to reconverge. So shut down the links, go into the end hosts. And actually, no, what I needed to do here is to exit out of the VLAN mode. So I didn't say end from the VLAN. It's not actually applying that config until I go back to exec. So you will see this with NXOS, just like certain features in regular iOS. You can run show commands from any mode in NXOS without having to use the do command, but there's certain features that don't actually activate until you exit all the way back to exec. So as a general rule, once you're done making a change, say end or do Control-Z, go all the way back to exec mode, and then it should actually apply it. So once we bring these links back up, now let's ping 20.0.0.3, and we have reachability. If we look in the core now, let's look at the show MAC address table, dynamic VLAN 20. We see those MAC addresses are now in the VLAN 20 table. So there's really no special configuration for this other than just specifying that the VLAN is running as mode FabricPath. And again, what that's changing is changing it from the classical Ethernet to FabricPath. We're also changing the traditional learning to the conversational learning, and then it's allowing us to encapsulate this from the classical Ethernet domain into the FabricPath domain. Okay, there's a couple other questions. How do I change the cost for ISIS FabricPath? Now, I don't want to go through all of the potential syntax. It could take us quite a long time to go through that, but let's look at the command reference here. So let's just go to the 7K command reference, which actually, let me start from the main documentation page so everyone knows where this is located. If we go through, let's go to products, switches, data center switches, 7K, reference guides, command reference, then FabricPath. Most of these are going to be self-explanatory once you look through this. So we could do authentication. So what's the keychain? What's the type? What's the ISIS metric at the link level? What are the timers? Are we generating a log message when ISIS adjacency goes up or down? MAC address table, learning mode, conversational. This is going to be, again, default for the FabricPath VLANs, but you can actually enable this for non-FabricPath VLANs, for your regular classical Ethernet. So even if you're not running FabricPath, you just have a normal layer 2 Ethernet, maybe you're doing VPC, if your MAC address tables are starting to get out of control, you could go to all your VLANs and change the learning mode to conversational, and that's going to save you some space inside the CAM table there. There's a question. I had mentioned that the leaf switch needs to be the root of the spanning tree. If you have 3 leaf switches that are all running the same access VLAN, all 3 can't be root. Are we forced to run 1 VLAN per access switch in this case? The answer is actually they can all be the root. So it's kind of another hack on the spanning tree process like we saw in VPC. It's a special behavior within the scope of FabricPath that you can have multiple leaf switches attached to the same segment that are all the same layer 2 root bridge for spanning tree. So you basically just go to the edge switches or the leaf switches, whatever VLANs are in mode FabricPath, you would also say spanning tree VLAN 10, spanning tree VLAN 10, 20, priority 4096 or priority 0. Set them to be the lowest value. Then it makes sure that their downstream classical Ethernet facing links don't get disabled because of the root guard. So all of the leaf switches ideally should have the same bridge priority in case they do end up being connected together with classical Ethernet. If they have different priorities and they do have classical Ethernet, then one of them is not going to be elected the root. It's going to cause the root guard to kick in, and then you're going to have some forwarding problems. There's a question, would you recommend that FabricPath be used if possible first in the data center and VPC Plus instead if you already deployed VPC? Ideally, you would be running FabricPath. The potential issue is going to be the cost of the feature, though, when you look at it versus VPC, because VPC you can run pretty much on any hardware. You can run it on the 5010s, 5020, 5548, the 7Ks with the M1 or the F1 modules, but FabricPath requires that you not use 5010 or 5020. So if you already have those as your end of row, then that's going to be a potential issue. Okay, the same would be true with the 7Ks. If you're already using M1 or M2 modules, then you're going to have to basically throw those out and use F1 or F2 because those are the only ones that support the feature in hardware. But if you're doing a new implementation, then yes, ideally you would want to run FabricPath because then you just simplify the network a lot here. You could do equal cost multipath. When you want to add additional resiliency or additional link capacity, the only thing you need to do is just plug additional ports between the switches, and then ISIS is automatically going to take care of that. There's a question, does conversational MAC learning greatly increase unknown unicast flooding? It actually does not, because the conversational learning is not an optimization of the data plane. It's only an optimization of the control plane. So you'll do normal unknown unicast flooding. It's just that you will only learn the MAC addresses once the response comes back in the reverse direction. When we come back, we're going to get into overlay transport virtualization. And then later this afternoon, we're going to talk about security on NXOS as well.